Today's lesson, we are going to do an introduction to quadratics. Before, we have learned all the graph is either a straight line or is non-linear, not a straight line. And today, we are going to learn a new function that is not linear, not a straight line, not linear function. So, first thing we want to see one example, and this one could be described by quadratics. So a particular mode grows in the following way. If there is one blob of mode today, so number 1 today, then there will be 4 tomorrow, 9 the next day, 16 the next day, and so on. So you need to model this relationship. First thing with some physical objects are cubes. So the purpose for this one is we want to find the relationship between the side lengths and the number of cubes. And we want to model that the number of days with the side lengths and the number of cubes model the number of mode. So we are going to see if it works. So hypothesis is, what type of relationship do you think exists between the side lengths and the number of cubes? Is linear or non-linear? So it's going to be a straight line or it's going to be a curve. So first day is 1, and second day is 4, and the third day is 9, fourth day is 16. If we draw it, do you think it will be a linear? So for hypothesis, there's no right or wrong. It's just what you think it may be. So I may just guess, non-linear. There's no right or wrong. It's just later we are going to see if our guessing is right or not. So this is just guess, just predict. Okay, guess, predict what it may be, the relationship. There's no right or wrong. So now we are going to consider the following model of cubes. Each cube is a 1 by 1 by 1. So 2 dimension is a square, then you extend the height to another 1. So it's 1, 1, 1, all the height, width, and the length are 1. So we call this one is cube. Then what would the next one in the pattern looks like? So we are going to see. So first day is 1, it's match. It's match this one. So first day is 1. First day you have 1. And second day you have side 2, altogether you have 4. And the third day, side 3, altogether you have 9 cubes. Then fourth day, we have 4 times 4, we have 16 cubes. So it matches our model. Then we want to predict the next day, how many cubes? So we know this is how we get 16 is side 4 times by side 4. Then we have 16. Then we predict the next one will be side 5 times 5. Then we are going to have 25. So this is a pattern here. This is a physical objects pattern. Now we want to use table of values and also the graph to build mathematical models. So we are going to complete this table including the first and second differences. I will explain what first and second differences means. So then we are going to graph it and draw a line of best fit. So for this model, if you have 0 length, then 0 times 0 give you 0. If you have the length is 1, then you have only 1 cube. And if you have the length is 2, then you will have 4 cubes. So we just fill in this table of values. And 3, we have 9. 4, we have 16. 5, we have 25. And what the first differences means, this one is just a rise. The difference of the y, okay, from 0 to 1, the difference of the second column. So 1 minus 0 give you 1. Then from y value 1 to 4, it will give you the rise is 3. Then from 4 to 9, the rise is 5. And from 9 to 16, the rise will be, the difference is 7. Difference means subtraction. So from 16 to 25, the rise is 9. So the difference means subtraction. The difference is subtraction. Then you will see rise, and if we see the run, this one is right one. This is right one. Go to the right side one, right one. So the run is 1 and the rise is different. We know the slope is rise over run. Then you will see the slope for each 2 points. Between the 2 points, the slopes are different. If the slope's different, then it's not going to be a straight line. If you have a straight line, all the rise over run must be same. So if the rise and the run not same, then we know that this is not a straight line. So rise over run, the slope not same. Then we want to see a pattern. We want to see if the second differences same or not. Second differences means the first differences subtract. Subtraction of the first differences, we call it second differences. And some of your teacher may show you the first differences. You could use dirt y, this symbol to represent first differences, and the second differences is dirt squared y. Okay, this triangle, we don't call it triangle, we read delta, like our delta mass. So this is triangle symbol, we call it delta, and what it means minus. Okay, it means minus, subtraction. Not negative, but subtraction, minus. So we are going to see the second differences means the differences of first differences. So differences means subtraction. So subtraction of first differences will give you 3 minus 1, give you 2. Then from 3 to 5, the differences is 2. 5 to 7, differences is 2. 7 to 9, the differences is 2. Then you will see for our model, they have a pattern. The second differences are same. And this is an important property for quadratic. Okay, so after we fill in this one, we find the first differences, second differences, then we know for our model, it has a pattern, second differences are same. And after that, we are going to make a scatter plot using the first two columns. The first column always is our independent variable is x, and second column is our dependent variable y. So this is x, this is y. Then we are going to find the points. Well, the first point is 0, 0. So 0, 0 is this point. Second point is 1, 1. So x is 1, y is 1. Then third one is 2, 4. So x is 2, right 2, up 4. Then the fourth point is 3, 9. So x is 3, right 3, up 9. Then next point, 4, 16. Right 4, up 16. And the last point is 5, 25. So right 5, up 25. It's here. So you have this scattered point. It asks you to draw a line of best fit. So this is not going to be a straight line. It will be curved. So I just connect this point together. Then you will see you have a curve instead of a straight line. So this is actually keeps going. So we put arrows on this side. This one side only because you are not able to extend this one. You are not going to have less than 0 sidelines. Okay, for real world measurement, all the measurements need to be positive. So the dotted line, we call it line of best fit. Okay, now you have drawn the first quadratic functions graph. So that is for quadratic function. So this curved line has a pattern that the second differences are same, and we use quadratic to describe it. We call it quadratic relation. The graph of a quadratic relation is called a parabola. It is something like a graph shown below. Okay, it's like a U shape. U shape. So it could open up or it could open down. So if U shape is this way, we call it open down. If the O shape is this way, we call it open up. So we have two different opening directions for a parabola. So now we are going to introduce some terms you need to know to describe the important properties for quadratic relations. The first one, the very important unique point is this point is a vertex. So we call this point is vertex. And the vertex is the highest or lowest point on your graph. So this is the lowest point, and if open down, then the vertex is the highest point. So either the lowest point or the highest point. We call that point vertex. And the other important points are these two, the x-intercept. So sometimes you have two, and sometimes you may have one, and sometimes you may have none. So I write it in a short form, it's x-intercept. And the x-intercept are the points that the parabola intersects with the x-axis. So we call the point of intersection with x-axis x-intercept. And we do have another point of intersection that is intersect with the y-axis. So this is y-axis. The point of intersection of the parabola intersects with the y-axis. We call this one y-intercept. So x-intercept, y-intercept, and y-intercept, always you have only one. It doesn't like x-intercept. Sometimes you have two. Sometimes you may have only one touch the x-axis. And sometimes you may have none. It doesn't touch the x-axis. So you have 0 x-intercept, 1 x-intercept, and this one you have 2, okay? So touch once, touch intersects twice, and this one doesn't have point of intersection with x-axis. And we have one more important characteristic for the parabola is axis of symmetry. Axis of symmetry. And in a short form, we write it as AOS, the first letter of each word, AOS, axis of symmetry. And this line divides the parabola into half. So if you turn the parabola this 180 degrees, it will overlap with this side. So we call this one is axis of symmetry. So now we are going to fill in the definitions for this important terminology, okay? So maximum or minimum point of the graph, we call it vertex. It's a point where the graph changes direction. So from going down to going up. So this is changing direction. And how do I label it? Use x, comma, y. So the graph A and B is on the next page. So you are going to find them from graph A, then fill in this chart here, okay? So we may label this one first. So for this vertex, we read from the graph, this is x is 5, y is -8. So for this one, the vertex is 5, comma, -8. And for the x-intercept for this point is 9, comma, 0. And for this point is 1, comma, 0. The y-axis coordinate on the x-axis, they are zeros. And for the y-intercept, this point, we are going to write 0, comma, is not exactly on 4 or 5. We could just write estimate approximately 4.5 or 4.3, 4.4 of them correct. So axis of symmetry, this is a vertical line, and for the vertical line on this line, all the x coordinates are same. So the equation for this line is x equals 5. So this one, the slope is undefined, is infinite, because you have the rise from this to this, you have the rise 1, but the run is 0. So right over run will give you the rise over run is 0, so 1 divided by 0 will give you infinite. So for vertical line, the slope is undefined, is infinite. So that is a vertical line. If it's a horizontal line, then we have the rise is 0, so the slope is 0. Okay, so vertical line, the slope is infinite. Now we are going to fill in the maximum, minimum value. If the question asks you for the maximum, minimum value for quadratic function, it is asking you the y value of your vertex. So normally we want to write a vertex, use the two letters P, comma Q to represent the x and y coordinate of the vertex. So the maximum minimum value will be the Q value. Okay, and this one I will write the definition is the y value, y coordinate of the vertex, that is a maximum or minimum. So if the graph is open up, then you are going to write minimum equals. This vertex will have a minimum value of the whole graph. All the other points, the y value will be greater than the y value at vertex. So you write minimum equals Q. And if the graph is open down, then you will have a maximum value at the vertex. Then you are going to write max equals Q. So this is how you are going to answer questions. If the question asks you for maximum or minimum value of a quadratic function, then you just either maximum equals Q or minimum equals Q. And for the axis of symmetry, the definition is a vertical line. A vertical line divides the parabola into half. The graph into half. And these two halves are equal, okay? They are equivalent. It's half-half, so you overlap 180 degrees, they will overlap. And the equation for this one, because it is a vertical line, so you could write it as x equals p value. The x coordinate of your vertex. That is the equation of your axis of symmetry. If we graph it, then you have a line at the middle of the parabola, divided the parabola into equal half. And this line is x equals p. And for the y-intercept, that is a point of intersection of the graph and the y-axis. So the graph intersects with y-axis. That is called y-intercept. And always you have x equals 0, then just read the y value on the y-axis where the graph intersects with the y-axis. That is your y-intercept. And the same thing for the x-intercept is the graph intersects with x-axis. And when we write is a point xy coordinate, the y value is 0. And also that is a reason the zeros is just a x-intercept also called zeros. The reason for it because at that point y value is 0. So we call the x-intercept also we call it zeros. They are same. So same as x-intercept. It's just another term for x-intercepts. So that is definitions for some important points or lines for quadratic relation. And now we are going to go to the next page and read the graph to see what is the vertex, what is the maximum, minimum value, what is axis symmetry for the following two graphs. So we are going to do this one, label the key features on the parabola below. So y-intercept. Y-intercept is a graph intersect with y-axis. So this is your y-intercept. And the value for that, we are going to count 1, 2, 3, maybe 3.2 or 3 is okay. It's not exactly on that point, so maybe 3.2. 0, 3.2. And the next one, vertex, the highest or lowest point. So this is the highest or this is the lowest point. And we label it 1, 2, 3, 4. So it's 4, 0. So this is your vertex. Then the 0 or x-intercept. This time it happens that the vertex is also the x-intercept or zeros for this graph. So this one is x-intercept. They are the same point. It is vertex and also it is x-intercept. And also we call it zeros. And the axis of symmetry, we are going to draw a vertical line here. Passes through the vertex, and this line we call AOS, axis of symmetry. The equation for this line is x equals 4. So we labeled this one, and now please pause this video and do the graph B by yourself. Once you are done, we are going to play this video and check your answer. So, and after that, we are going back to fill in that chart first. Okay, so this one, the graph A vertex is 4, v comma 0. The maximum minimum value is open up, so you have a minimum value. It should be the y value, 0. Axis of symmetry is just x equals the x coordinate of your vertex is x equals 4. And the y-intercept, we read it from the graph, is 0, 3.2. Or 3.1, 3.3 is approximately, this is that number. And x-intercept for this one is vertex is also the x-intercept, and you have only one, or we call it two equal x-intercept, two equal zeros. So that is for graph A. Now we are going to take up answers for graph B. So we find the y-intercept first. So y-intercept this time is a nice one. So y-intercept. And the x value is 0, y value is 2. Vertex is the lowest or highest point. So 1, 2, 3, 3.5 is around. X value is 3.5. Y value is 1, 2, 3, 4, 5, 6. So the vertex is 3.5, comma 6. And for the zeros, we are going to look for the point of intersection of the graph with x-axis. So you have two. This one is x-intercept, and this one is x-intercept. Then we write the xy coordinate out. So this one is -1, comma 0. This one is 1, 2, 3, 4, 5, 6, 7, 8. 8, comma 0. And the axis of symmetry is a line passes through the vertex. Vertical line passes through the vertex and divided the parabola into equal half. Okay, so this one, vertical line on this line, all the x values are same. So x equals the p value, the x coordinate of your vertex. So x equals 3.5. Then we are going back to copy all these answers in this chart. So graph, this one is 3.5, comma 6. It's open down, so you have a maximum equals 6. The axis of symmetry is equals the x coordinate of your vertex, and y-intercept is 0, comma 2. X-intercept is -1, comma 0, and 9 is 7, comma 0. It's 8, comma 0. Okay. So it's 8, comma 0. So you have two x-intercepts, and the zeros same. -1, comma 0, 8, comma 0. Okay, so you need to know all these terms, and you should be able to read the information from a given graph. And now we are going to see this is a real world application. So a bird spots a fish and dives from a cliff. that is a 3 meter high. It follows a parabolic path so that it enters the water 1 meter from the base of the cliff and exits the water 3 meters from the base of the cliff. You have two expressions could be used to describe this diving. Then we want to do some investigation to see this is a square that we call the quadratic relation. If the highest degree is squared, then it is a quadratic relation. We want to see if the second difference is same or not. So we are going to create a table of values first, then we use that table of values to do a graph. Now we sub in x equals 0. So these two expressions are equivalent, so we are going to just use one of it to fill in the table of values. So we are going to see, let me just pick the second one to do the table of values. So when x equals 0, we do the substitution. Then we sub in 0 here, you will have y equals 0 squared minus 4 times 0 plus 3. Then use your calculator, 0 squared give you 0. So by math, do the exponent first, then do the multiplication. Don't 0 minus 4 first. You need to do the multiplication. 4 times 0 give you 0, then plus 3. Then we are going to do the adding, subtracting from left to right. Not doing the addition first, okay? The bad math. For division, multiplication, it's not division first. You do it from left to right. And the same thing for adding, subtracting, you do it from left to right for these two. So you have add, but don't do adding first. You do it from left to right. So 0 minus 0 give you 0. 0 plus 3 give you 3. Then this is 1 point. 0, 3 is the first point. Then we are going to do 8 for x equals 1. Then we sub in 1 to this expression, replace the x with 1. You will have 1 squared minus 4 times x is 1 this time. Then plus 3. And do the calculation, you will have 1 minus 4 times 1 is 4 plus 3. Then 1 minus 4 give you negative 3 plus 3 give you 0. So the second point is 1, 0. Then continue x equals 2, y equals 2 squared minus 4 times 2 plus 3. You will have 2 squared is 4. 4 times 2 is 8. Plus 3, then do the calculation from left to right. You will have negative 1. Then we are going to do x equals 3. Then y equals 3 squared minus 4 times 3 plus 3. Then get your calculator out, you will find out it's 0. So this is a negative 1, this is 0. And x equals 4, we do the calculation. Y equals, replace the x with 4. So 4 squared minus 4 times this one change to 4, then plus 3. You will have 3. So this is the points on the graph. And after that, we want to do the differences, okay? So the differences means the y value, the rise. Find the rise on the y value. So from 3 to 0 is down 3. You do the subtraction. And from 0 to negative 1 is down 1. From negative 1 to 0 is up 1. From 0 to 3 is up 3. Okay. Then we are going to see it's just subtraction. You could just do 0 minus 3. The bottom y value minus the y value above. Then we are going to do the calculation of this one. This is a minus again. So it's difference means subtraction means minus. So negative 1 minus negative 3 is up to negative 3 to negative 1 degrees. You could see the temperature, negative 3 degrees to negative 1 degrees is up to. Negative 1 degrees to 1 degrees is up to again. 1 degrees to 3 degrees is up to. So if you do the calculation, you just use a number at the bottom minus the number above. 3 minus 1 give you 2. Then you will see it is true. The second differences are same for a quadratic equation. The quadratic equation relation is the highest degree is squared. If it's a squared, then it is a quadratic relation. So now we are going to use the first two columns to find the points on the graph. So the first point is 0, 3. So x is 0, y is 3. Second point is x equals 1, y equals 0. So x equals 1, y equals 0. It will no up or down. 2, negative 1. So write 2, negative 1 means down 1. 3, 0. So write 3, no up, down. This one 4, 3, write 4, up 3. Write 4, up 3. So the x coordinate is left, right, y coordinate is up, down. Okay. Then we connect these points. You will see, yes, it is a U shape. It is a problem. So this is how you are going to, for now, how you can graph it and how you are going to be able to tell which one is a quadratic relation. So for quadratic relation, you look for, if the expression given, you look for the squared. Okay. If you have the squared, then that is a quadratic relation. If a table of values are given, then you look for the second differences. If second differences are same, then it is a quadratic relation. If a graph is given, then you look at the graph to see if it's a U shape. And sometimes you will see on the last page, we have half of the U shape. It is still a quadratic relation. So this is how you are going to use table of values to do a graph of a problem. Okay, and you need to know all these terms: vertex, lowest or highest point, x-intercept, find the points on the of the graph, intersects with the x-axis. And y-intercept is a graph intersect with y-axis. And The axis of symmetry is a line passes through the vertex. It's a vertical line, okay? AOS. So this is all the terms you should know. And now we are going to see the next page. The next page is we have the graph given, then you read the zeros. So these are two graphs and describe these two quadratic relations. So it asks you state the zeros from the graph given. So we are going to see from this graph you have the x-intercept. One is 1, 0. Another one is 1, 0. Another point is 4, 0. And for this graph, you have 2 and 6. So you have 2, 0 and 6, 0. And look at the equation given. What did you notice? You will see the zeros is the number that opposite with the number inside the bracket. So in future, if you have this form, we call it factored form. Then you are able to read the zeros from the factored form directly. The zeros is just a number inside the bracket, but opposite. Okay, so we are going to write the zeros are the opposite number in the bracket. Are the opposite of the number in the bracket. This only applies when inside the bracket x at front of x the number is 1. Okay, if it's 1x minus 1x minus, then the zeros will be just the opposite of the number in the bracket. So, and part 2 we are going to practice on why we have, like what we did before, why we have these two expressions equivalent. So part 2 we are going to see how we are going to convert from the factored form to standard form. So we want to start with what we know before. We times two numbers together, 32 times 54. If we don't want to use a calculator, we could use a box, an area model. So 32, we could write it as 30 and 2. 54, we could write 50 and 4. So one side of the rectangle is 32, another side is 54. Times these two sides together, you will have the area of this rectangle. So we also call this is a rectangle model. And we are going to find the areas of each rectangles. So you have 4 rectangles. We are going to find the area for each of them. So for this one, the length is 50, the width is 30. So the area is length times width. We times these two numbers together, you will have 1500. And for this area, one side is 30, another side is 4. This is not in scales, okay? So 30 times 4 give you 120. Then for this rectangle, the area is 50 times 2 give you 100. And for this area is 4 times 2 give you 8. So without a calculator, we are able to find the area, find the multiplication of two numbers by using the area model. So it will be add all of them together. So 1500 plus 120 plus 100 plus 8. Then we are going to have 1728. So this is a area model to find two numbers times together. Why we want to use this area model? Because we could model these two binomials times together using the area model. So one side is x plus 3, another side is x plus 2. You could switch these two sides. You will get the same area. So for the first rectangle, one side is x, another side is x. Area is times this x together, you have x squared. Then for this area, one side is x, another side is 3, times together you have 3x. Then for this box, the area, one side is x, another side is 2, length times width give you 2x. And for the last box, 3 times 2 give you 6. Then for the x plus 2 times x plus 3, by using the area model, we know how to find the expanding of these two. Simplify. So 3x plus 2x, we can collect the like terms. It will be 5x, then plus 6. So this is what you learned today, is how to expand a binomial two terms times two terms by using an area model. Draw 2 by 2 box. You have two terms, then you have 2 by 2 boxes. So this is expanding. Now we are going to use this method and try to expand. So this one, we are going to continue to use a area model or box method. And for this one, I will show you another method. It's just distributive method. So we do this one first, draw a box. It's 2 terms by 2 terms, so we have 2 by 2. You could write it this side or you could write it this side. It doesn't matter. So we may just write x minus 2, x plus 4. This way, then we find the area for each box. X times x give you x squared. Then 4 times x give you 4x. Find the area. Negative 2 times x give you this area, negative 2x. Then the last cell, last box is 4 times negative 2 give you negative 8. Then we are going to write the answer out is x squared. Then combine the like terms. 4x minus 2x give you plus 2x. Then minus 8. Then it's done. And for the next one, I want to show you a different method called distributive property or the rainbow method of FOIL. So FOIL, F means first term times first term in the bracket if you have binomial times binomial. And for the O, it means outside times outside. Outside times outside, so I will rewrite it again. So first term times first term, we call it F. Then outside times outside is O. Inside times inside is I. Last times last is L. So it's FOIL, four terms. So first times first. Outside times outside. I inside times inside. L last times last. Then we are going to have first times first is x squared. Outside times outside is x times 5 give you 5x. Inside times inside is 1 times x is 1x. Last times last is 5. Then we combine the like term. You will have x squared plus 6x plus 5. So this method, we call it rainbow method or FOIL. Or FOIL, F-O-I-L. So F represent first. So F is FF first. O is outside. I is inside, and L is last. Okay, so it's double of this later for the FOIL. Then the next one, I will use this one, we call it area model or box method. The next one, try it by yourself. Pause the video and you pick one of these two methods. Either use a box method or rainbow method. You don't need to know both of them. As long as you have the final answer correctly, then it's okay. So now try the last one. Then after you finish it, you check your final answer is correct or not. So for question C, I'm going to use a FOIL because we don't need to draw the box. It will be less space you are going to occupy. So first times first term in the first bracket times first term in the second bracket. So x times x is x squared. Then outside times outside. X times -5 give you -5x. Then inside times inside is -3x. Then the last term in both brackets times -3 times -5 give you +15. And this method also you could remember is just first term times each term in the second bracket. Then second term times each term in the second bracket. So you could use a FOIL or you just use first term times each term in the second bracket, then second term times each term in the second bracket. Then collect the like terms. So expanding is same as simplify. The final answer should have no brackets and no like terms. Then it's done. So check your answer. If you use the box method, you got the same answer, then you got it right. So no worries which method you are going to use. So in this part, we learned how to times the two terms times two terms. Then you could use box method, collect the like terms, or you can use a FOIL first time first, outside outside, inside inside, last last. But this FOIL only works for two terms times two terms. And if you remember first term times each term in the second bracket, then second term times each term in the second bracket, this method could be used for more than two terms. So just one term times each term in the second bracket, then the second term times each term in the second bracket. If you have the third term, then third term times each term in the second bracket. You combine the like terms, you will have the final answer. So now we are going to see the last page. The last page is kind of combine what we have learned in this lesson. So rewrite each equation in the form by expanding and simplifying. Then indicate the zeros, or we can call them x-intercepts and y-intercept. So from this one, we call factored form to find the standard form. So this one, we could use a first term times each term in the second bracket. You will have x squared minus 4x. Then second term in the first bracket times each term in the second bracket. So negative 1 times x give you negative 1x. We don't need to write the 1 at front, just minus x is okay. No numbers means 1 at front. Negative 1 times negative 4 give you positive 4. Then we are going to collect the like terms. Like terms are terms with same variable, same degree. No degrees means 1 for the degree. So we have x squared minus 4 minus 1 give you minus 5x, then plus 4. And for the x-intercepts, from this factored form, you have 1x minus 1, 1x minus 4, no numbers at front of x. Then the x-intercept will be just the opposite number for the inside the brackets the number. So opposite of this number. So opposite of negative 1 is positive 1. And another 0 will be 4. 1 and opposite of negative 4 will be positive 4. On third math, you are going to type in, they have a plus sign, click this plus sign, then it will give you two boxes. Then inside the two boxes, you are going to type in 1, 4. This is not for 1 point, this is for 2 zeros. So it represents 1, 0, and 4 zeros. So it represents 2 zeros. So it represents 1, 0 and 4, 0. So the dirt mice the answer is not, the format is not good. So 1,4 is not a point 1,4. It is represent 1, 0 is 1, 0, comma 0, another 0 is 4, comma 0. Okay, the zeros are 1 and 4. So on the graph, you will see you have 1 and 4 here. Okay, so it's not a point 1, comma 4. It's represent you have two zeros. So for standard form this time, I want to show you the box method. So pick one method, either this rainbow method or box method. You don't need to must know both of them. Okay, one of them is okay. So one side is x minus 2, another side is x minus 6. You could switch them, x minus 2 here, x minus 6 here. The final answer will be same. So x times x give you x squared. This side is negative 2, this side is x. The area for this box is negative 2 times x is negative 2x. And for this box, one side is x, another side is negative 6 times together give you negative 6x. The last box, one side is negative 6, another side is negative 2 times together give you 12. Then we collect the like terms. You will have x squared negative 2x minus 6x. They are like terms. You will have minus 8x. Then plus 12. This is your answer. Check. And for the x-intercept, it will be opposite of this number. So opposite of this number, you have 2 and 6. And for y-intercept means x equals 0. So x equals 0, then we sub in 0 squared minus 5 times 0 plus 4. 0 minus 0 is 0, so the 4 is your y-intercept. And in future, you will see if the equation is in standard form, we sub in 0 for x, you will have c left. So c is always your y-intercept if it's in standard form. So from here, we are going to see this c value is your y-intercept. You don't need to sub in x equals 0 all the time. We know that the y-intercept is a c value. And now pause the video and try the question C and D by yourself. Once you complete the two questions, then check your answer. So now we are going to do this one. I will do the rainbow. It's just save space. So x times x give you x squared. First term in the first bracket times each term in the second bracket. So x times x, then x times 5 is 5x. Then second term in the first bracket times each term in the second bracket. So 2 times x with the sign positive 2 times x is positive 2x. Positive 2 times positive 5 give you 10. Then combine the like terms. You will have x squared plus 7x plus 10. Then this is done. And for the x-intercept, it will be the opposite of the number in the bracket. But this only applies to the factor form. No numbers at front of x means it's 1. Then opposite of positive 2 is negative 2. And another one is opposite of positive 5 is negative 5. And also I want to explain why it works, because we sub in negative 2 here. Negative 2 plus 2 give you 0. 0 times another bracket gave you 0. So if we have the x value is opposite with this number, then negative 2 plus 2 always give you 0. And 0 times anything give you 0. So y is 0. Then you have a point, negative 2, comma 0. That is the reason why the opposite number is your x-intercept, because you sub in negative 2, you will have y equals 0. So negative 2 comma 0 is one of the point on the graph, and this is your x-intercept. And the same thing for the negative 5. You put negative 5 here. Negative 5 plus 5 is 0, so 0 times another bracket give you y 0. So another point is x equals negative 5, you will have y equals 0. And this point, it is the point on the x-axis. So that's the reason it's opposite. So this one, standard form, I just do this one, x squared, the rainbow method. X times negative 3 is negative 3x. 4 times x give you 4x. And 4 times negative 3 give you minus 12. Collect the like terms, same variable, same degree. Negative 3x plus 4x give you 1x. We don't need to write the 1 at front. By default, no numbers, it's 1 times x, means it's 1. Then minus 12. The x-intercept is opposite, negative 4 and positive 3. You sub in, you will have y equals 0. For x-intercept, always the y will be 0. And these are the values make the y equals 0. So y-intercept is just a c value, negative 12. And this one is c value is 10. So check your answer. If not right, replace this video and see where you didn't get correct. So that is all for today's lesson, and today we don't have the online homework. We have only paper pencil homework, and please, once you get your homework done, put them in the Dropbox on D2L. Dropbox 1.3 on D2L. And how are you going to put this one on the D2L? You are going to log into D2L and select our course MPM 2D. Then on the bar, you are going to click on the Dropbox. So there is an icon. It's called Dropbox. Click on it. Then you click on 1.3. Then you click on add a file. Then you attach add a file. Then you attach your pictures and submit. So after you attach them, then submit. Okay, and if you have trouble to submit it in Dropbox, please email me, ask for help, or you could temporarily, you can send through email. But if you don't know how to submit your file into Dropbox, please don't hesitate to ask for help. Okay, so here for the practice set 1.3, multiplying binomials, the answer is at the bottom, and for the D, the answer is not correct. Change it to minus 17x, not minus 12x. And also the next page, you have the read information from the graph, and the answers are posted on D2L. And now I want to show you how you are going to submit your homework to D2L. So you scroll down, find the MPM 2D 1-6, then you will see you have Dropbox here, and you have 1.1, 1.2, 1.3, and for today's homework, you click on 1.3, and I will change my setting to students, and this is what you are going to see. So I just show you another one. So for example, you want to submit your file to Dropbox, you click on one of the Dropbox, then add a file, then you click on my computer, then you could go to File Explorer and drag your pictures drop here. Or you could click on this one, upload, and find where the files will be. Then click on the file, then open, then click add. Once you click add, don't forget you need to click on submit. Then if you click on submit, then you will see you upload your file to the Dropbox successfully. Okay, this is how you submit your file to Dropbox.